Hello, everyone. Good afternoon or good morning or evening from wherever you're joining us today. We have a great session lined up for you and some esteemed panelists as well, which I will let them introduce themselves. So first up, we have Catherine Gull from Cellnex Telecom. Catherine, can you give us a bit of an overview as to your role and what you focus on at Cellnex?
So I'm Catherine Gull, and I'm head of business development and partner management for Cellnex Telecom based in Barcelona. Over the last almost 9 years, I've been working on private networks, moving from 4G to 5G and really looking at different opportunities in manufacturing, mining, ports, airports, etc., where 5G, 4G, moving into 5G could really make a difference and help to transform their business.
Perfect. Thanks so much, Catherine. And next up, we have Samara Geissah from TELUS. Samara, do you want to quickly introduce yourself?
Thanks, Yesmean. Yes, Samara Geissah, Director of Technology Strategy and Architecture at TELUS. Our job is basically to interface with our customers, understand the problems that they're looking to solve, and using technology and solutions, some we own, some we partner with, to address these challenges.
Perfect. Looking forward to getting your thoughts on that too. And last but not least, we have Aparajithan Sivanathan from AMRC, or otherwise known as SIVA, from the Advanced Manufacturing Research Center up in Sheffield. SIVA, do you want to introduce yourself really quickly?
Hello, I'm Siva, and I am the head of digital technology at AMRC. I'm also leading the consortium called 5G Factory of the Future. This is an aerospace-based 5G testbed. A little background on AMRC. AMRC is a research center trying to accelerate the adoption of technology within manufacturing. We have a particular focus on aerospace, but we also look at other types of manufacturing. I'm basically an electronics and software engineer.
Perfect. So Siva, why don't we start with you then? So from the work that you're doing, let's start with the manufacturing industry. Where is, the manufacturing industry at and the adoption of 5G? And also to your point in the introduction, the manufacturing industry is quite a broad one, and there are multiple different segments. But can you talk a little bit about, what you're seeing across the different areas of manufacturing, if you will?
The primary interest on manufacturing is mostly around the flexible manufacturing. There's a very common concept called flexible manufacturing. So you don't make a lot of products, but instead you make one product of a type, and then you continuously change or customize your product. So, this is where 5G becomes very interesting, but that's not the only area, but this is where it's becoming very interesting, because you had to change the configuration of your manufacturing facility every time. Like, previously it's supposed to be weeks lead time, not anymore, because you can just, go and change the physical infrastructure without losing the connectivity. So you will retain the invisible link, but technically you're reconfiguring the cell or the manufacturing functional elements to a different setup. That's a huge advantage. Apart from that, there is this mobility. So robots, anything that moves, that needs a lot of bandwidth. That's 5G is a no-brainer for us. The third one is not well appreciated, but that's the other area. Like even when you have mass production with lots of machines and all those, the infrastructure costs eventually add up to a lot of amount. But if you had to have a layered network, certain types of machine go into one type of switch, and another certain type of machines, and the robots go into Wi-Fi, the cost adds up, and then it will eventually become competitive to 5G installation. even though at this stage it's slightly expensive, but it's still competing with a well-established technology like wires. These are the primary areas of interest for now. Again, like private 5G seems to be getting the traction in the first place, but the public-private interface will be more interesting in the logistics area when you are trying to interface with suppliers, larger tier 1 companies, and then their supply chain consisting of hundreds of smaller companies. Then you can literally bring them all into one umbrella connectivity. If we have some kind of a public network providing you that guaranteed secure private channels or private slices at some point.
Yeah, and that's an interesting point, and I want to get to that a little bit later as well. And you actually took one of the questions I wanted to ask around this whole debate between public and private. Catherine, maybe I want to move on to you in terms of, we've gotten Siva's thoughts on what's happening in the manufacturing sector, but how does this compare with what's happening in the mining industry?
I think there's a lot of commonalities between the two industries. One being mobility and the use of robotics and AGVs. I think layering on manufacturing is dangerous, and mobility and robots and machines working at the same time as human beings is a dangerous situation, or any kind of machines actually. I think that one of the most dangerous machines in a manufacturing to logistics plant is a forklift, because people get caught in front of that. Whereas an autonomous vehicle, you've got not a human who's distracted in place, but you've got a machine who knows, oh, stop here, etc. So I think the commonality between manufacturing and mining is those things like autonomous guided vehicles, and those things that can go, those vehicles and those robots that can go in those dangerous places where we really don't want humans. And so that's a real key driver for private 5G and 5G in my mind. The other thing with mining, which is mostly different than manufacturing, is it's usually remotely located. So matching that public to private, it's usually public, patchy, not so good. So private, very necessary in order to maintain the safety, in order to maintain business as usual going forward. So that's a real key thing with mining, I think. And the last thing with mining is those underground mines where vehicles and people need to go. They need to be monitored. Again, it's everything from preventative maintenance. It's being able to fix things just in time before you get someone who's having an issue. And then also being able to track where individuals are, heat map them, whatever it is appropriate, in a kind of an IoT fashion to keep people safe. So I think that those are the key drivers as compared to manufacturing in mining.
And interesting as well, because, one of the things, as you mentioned, is, that mission criticality, right? The need to almost, protect, the workforce who are on the premises, on the mines, or in the factories themselves. I guess another question is, how does that relate in terms of this debate that we're having in the industry with regards to private LTE versus private 5G?
So for me, private LTE versus private 5G is really about what the applications are and where a business wants to go with their network. So private LTE is sufficient for a lot of the tracking of individuals. It's also sufficient for a lot of the preventative maintenance. Where you really get 5G is where you've got low latency, big bandwidth, and also lots of things, lots of IoT things to manage. So there's hundreds versus in some cases thousands. And that's another key use case for looking toward 5G. I think Siva can probably comment on that. One of the projects that I started working on with him was looking at tracking where different things were in the factory. Now, granted, those were really large things, but it was a key thing.
I think that's a valid point, Catherine. So private LTE is adequate for certain types of use cases, wherever the time criticality or the bandwidth is not hugely an importance. There is another aspect, at least in UK's terms, the frequency availability. The LTE frequencies are quite competitive because they are all owned by MNOs. There's a very narrow, band available if you wanted to do for other setups. But the public, unless you work with the MNOs, the private LTE is a difficult one to achieve. But that's not the case for the private 5G because the shared spectrum availability is quite massive. There's a decent 100 megahertz available for anybody to use it with a significantly lower cost. Again, this is also linked to how the businesses wanted to work with the MNOs. Say, for example, the connectivity is something the business has always held next to their core function. Will you happily outsource it to an MNO in the first place? That trust needs to be won before it can be deployed into a private MNO style installation. However, the private 5G is slightly different because you can own the spectrum, you can own the hardware, everything. It's not a very big transition from how they used to operate now. So that's a big difference in my opinion. So it's more towards the policies and the working practices than the technicalities here,
Yeah, and that's interesting as well. Samar, I want to get your point of view in terms of, what's the current state of activity at the moment in terms of, the exploration and adoption of 5G and the types of opportunities you're seeing across, the manufacturing and the mining sectors.
Yeah, that's a really good question because it really differs, as Siva and Catherine mentioned, market by market. And in Canada, a lot of our mining and manufacturing customers have had to deploy wireless, non-3GPP wireless solutions, Wi-Fi to a large extent, some proprietary radio interfaces. And they're finding that technology is not really evolving into what their needs are. So we usually start our engagements with, okay, what is it that you're trying to solve? Like, what's the problem? That's the one problem that you're trying to solve with technology. And it takes a bit to explain what the technology does, but really the source of the solution is defining the problem very, very correctly, right? So a lot of what we saw is an evolution from Wi-Fi to LTE. LTE seems to do a lot more than Wi-Fi in terms of mobility. Excuse me. And then the other aspect is that the evolution, as mentioned by Catherine, towards 5G is really dependent on the needs for low latency, intensifying the number of connections. So within a manufacturing plant, if you categorize the use cases, number one, usually the foot in the door for somebody just dumping what they used to have and going into LTE and 5G is safety and security. So we did a lot of work on worker safety, identifying if people are, the workers on the various parts of the plant are actually wearing the right protective gear. So in a manufacturing plant, you would have different sections, each have their own rules in terms of what you're allowed to do and how, in what way you're dressed. So, a heavy down press in a manufacturing plant, you can't not wear the right protective gear. That's where video analytics comes in. And if it was going to be wired and it's going to be changing with the various production lines changing for different types of products, it's going to be a very difficult hassle to manage. So wireless becomes very usable. We talked about in a plant or a mine, autonomous haulage vehicles or vehicles or robots that simply move from A to B in a repetitive manner. Well, guess what? That's great, but they need to be aware of their surroundings. They need to be ready for unexpected results. And that's when you start thinking, okay, I need low latency. And low latency needs to be sub like 20, 30 milliseconds in order to be safe. So again, that's the exploration phase of some of the use cases, but it's clear to us that the various early questions that come in, and we've done already a couple of deployments in private wireless in mining, for example, and the early feedback is that's much more superior. The device ecosystem is already out there. And then the one device that, for example, a worker would wear, there's no longer the need to have mission critical push-to-talk, walkie-talkie. You have another bunch of sensors that you're wearing to detect gas. You can actually combine a lot of this into one device and then use the video analytics as a third mechanism to keep everyone safe. So that's where it's at in terms of both industries. But the discussions, as soon as you talk about one problem, you see the various other areas you can solve with that private wireless, and it becomes a huge wish list for us to execute together with the customer.
Yeah, and that's really interesting as well, because going to Siva's point around, that need to move towards flexible manufacturing. And, Catherine, you and Sam are both talked about sort of the mobility aspects as well, and how, it is really important to be able to combine the two and ensure that you're inherently integrating that flexibility into the way that, let's say, a production line is, or a production floor, shop floor is laid out, so on and so forth. Mm-hmm. I guess just a question as well, because Samar, you touched on the point that, a lot of the initial discussions often, rely or are based around things like worker safety, security, and obviously, some of these industries are heavily regulated as well. And there are a lot of, issues and things to be aware of. And then you mentioned the fact that, there are then other pain points that start to emerge as well. Catherine, to what extent is this often sort of an opportunity and a challenge? Because it's an opportunity because there are so many things that can be addressed, right? With a private 5G network, for example, but a challenge in the sense that there are lots of different stakeholders who are involved in that decision making. How do you navigate that challenge? Oh, you're on mute, by the way.
Sorry. It is a huge challenge because not only are there so many stakeholders, but it's also sometimes it's a change of doing how to do business. And that, I think, is the biggest challenge, is getting someone who normally might have been in a vehicle driving around who is now either monitoring the autonomous vehicle, or let's say it's a remote control, driving the remote control vehicle. So it is a real big challenge. And some of the ways to do it is to focus on where the business's pain points are. We've talked about safety. Almost every time a business makes a decision immediately fast about safety, they've had a safety issue and they have no choice. Sadly, that's the way it goes. We're talking, it's been in the news for the last, at least since COVID, if not before, getting people to drive those trucks, drive those lorries, almost impossible. There's a lack of them throughout the world. It's not just the US or the UK or across Europe or Canada. They're just not there. I remember 5 years ago talking to a port and them saying, "Oh, we can't find anyone to drive the key cranes. Nobody wants to come out of school and drive a key crane, but they might want to be the remote control driver of a key crane." And so it's helping a business shift how they do business according to the pain points that they're having. I think Samir and both Siva said it's really looking at those pain points. Where are those pain points? And then, as Samir said, then the list starts building. And that's when you get traction. But it's really finding those places, and it's different in every business of, what's hurting, what needs to be transformed, what's going to make their business work better. It could be the falling down of a machine that they've had for a long time. And if you lose the machine for a day, you lose X amount of business. You don't deliver. We're in a slightly different world. We've been pushing toward this world where people don't want to drive vehicles. They don't want to work in manufacturing plants. They don't want to do those safety intensive health and safety kind of jobs where, highly regulated, yellow jacketed jobs, for lack of a better way of putting it. I don't understand why, because I think, there's opportunity everywhere, but it's going to change how a business has to keep continuity.
And I want to explore that a little bit further. And Steve, I want to get your thoughts, because you made a comment earlier around a slightly different area, because you talked about sort of the ecosystems and logistics, but I want to even just explore sort of that ecosystem of within, let's say, a factory, for example, of different types of use cases, and they're all interconnected in some way, shape, or form. And what are your thoughts on sort of that opportunity that, that is it the sum is, the whole is greater than the sum of its parts, that saying? What are your thoughts on what that can actually enable in terms of connecting multiple, silos within that same environment?
I can talk about the use cases we do at the moment. Our use cases are quite common across other manufacturing deployments as well, but everybody comes up with their own flavors to that. One of them is fundamentally the real-time control of manufacturing processes. Normally, if there's a machine or robot doing a task, manufacturing, it could be an inspection, it could be an assembly on a hazardous environment. You leave the critical intelligence in the robot or in the machine, in the CNC machine. The reason it was designed that way, because, the machines and the software stacks and all of them were limited by the connectivity. You didn't have a central place to process all of them because you don't have that fast link between these two. So, Catherine was talking about the robot teleoperation, and Samir was talking about that too. So if you don't have that 20 millisecond latency, it might be too late. So we do cut titanium and very expensive materials for aerospace. If you made a damage, it's damage already. So one of our use case, we have a target about 15 milliseconds round trip. So the moment you sense the vibration, and then you take it over the air and then dump it on an AI platform, and then bring it back to the control signal or correction signal to the machine. The budget we've got is 15 milliseconds. It's already a challenge for everything. It's a challenge for AI, it's a challenge for the 5G and all those. Why do we have to do this? It's just because it's going to change the way of the businesses operate. You can remove the intelligence. If you can remove the intelligence away from the process, then you have, there's a different way of managing the intellectual property. You can come up with very sophisticated algorithms to control the machine or robot, but you can open up this to a different world. Like now you need to pay very expensive salaries to those machine, programmers. But the numbers come smaller and smaller now. But then on the other side, there's another domain like data science is booming. So why don't you make use of these data scientists and then the tools available in the data science in manufacturing? But what's the missing piece is this connectivity, because if you have this connectivity, you can certainly unleash a massive high performance computers resources to a machine which used to run with a small tiny net-top PC. So that's one of the use cases. The other one is like the logistic and the supply chain, right? So even if you outsource the manufacturing or any sort of operation, you can still have a visibility of what's happening to your part or product while it's in somebody else's jurisdiction. So there's no way of faking it. There's no, because the data is growing with the part. The data is being generated while the part is being manufactured. So the digital twin is growing with the actual part. Regardless, it doesn't need to be in your custody. It could be in somebody else's custody down the supply chain. But then you have this chain of custody from one supplier to another. And then we are also thinking about how about second life, about batteries and all of them. So even if you use the battery on a car, you can maintain a digital twin of a battery while it's being made, while it's been in the car. And then at the end of the car life, if it's going to, the simple soft life of energy storage, that's not demanding as an automobile, but you can still maintain the data through that. So it's all enabled by the connectivity. I think that this is where it's going to come from, in the future.
Yeah, and it's interesting as well because, as you mentioned, it really opens up this new degree of almost servitization and new types of business models. So, for example, if you, if you're responsible for powering, let's say, or providing the engines that fit into multiple different things, you might want to understand, well, how are those engines used in any given environment with, by your customers? But again, it kind of it involves or requires a certain degree of scaled adoption, right? And Samer, how far are we from that vision, if you will, or how far do you see that being?
I think we're at the stage where the realization of the importance of the data in decision making in the various industries. I mean, it's always been there in terms of measuring efficiency of production or measuring efficiency of, mining for specific types of minerals. But I think it really gets very complex area by area. And let me just give you an example. In a mine, there are different types of mines, obviously. You're underwater, you have subterranean, they have on-surface mining as well. Each one of those has its own set of challenges. And data is used very differently from one aspect to the other. Covering with wireless technology and under or terrestrial, in the ground mine, they're very different. They're very complex. Take that into other industries in manufacturing, oil and gas, the web of metal structures that constitute either the manufacturing process itself or the compression of gas, etc. All of those are again very different aspects of important pieces of data that need to be aggregated, tested, conditioned, and then projected via machine learning algorithms that then give back feedback. So 5G comes in and says where you can move huge volumes of data. Not only that, but now with the capability of private wireless networks with multi-access edge computing, you can actually get most of the decisions you need to do in real time on-prem, and you don't need to depend on backhauling all of that traffic. And as we discussed, a lot of mines are very remote. There's probably no public coverage in the area to depend on. So you have to depend on your backhaul capabilities via LEO satellites or other technologies to be able to backhaul that traffic. So you really don't want to use public cloud in the sense of the traditional factory. You might be able to use some aspects of that. So I think there's a realization that first 5G becomes real with the private wireless network use cases to begin with. 5G becomes the real answer to some of the most critical questions as to safety. We talked about mobility. We talked about all of the access, increasing production via digital twin. You need to have that capability of local processing and local connectivity under no constraints of, oh, is this going to, interfere with my other operations? So you want to give them the flexibility to move things around. You want to be able to give them the capability to have a device instead of carrying three. And if you want to talk, big dreams, I often heard the example of remote surgery over 5G. That's great, but I think first step, we talked about autonomous haulage vehicles. No one is going to simply deploy one out there. They're going to go through a stage of maybe remotely operating, and then semi-autonomous, to somebody there, guiding it, making decisions if they have to, all the way into full autonomous. And that journey is fully dependent on data. And then, of course, when we talk about it as connectivity providers, people don't come to us for all these third-party solutions, although as TELUS, we actually own a lot of our own solutions in agriculture and health. But in the other verticals, we have to depend on our partners. So we work with our partners to say, here's a combination of basic building blocks that actually could solve some of those early identified use cases. And then from there, we branch out as well. Additionally, now that you have the connectivity, now that you have the low latency, now that you have the local multi-access edge computing capabilities, here's what else you can do. And in fact, we actually promote co-creation and co-innovation with our ecosystem partners. And we created multiple innovation hubs in Canada that address various verticals, because we believe we don't have the answer. We're very humble about that approach. We don't know what we don't know, but working out there with our customers to take a challenge into one of our 5G labs across the country, showing that the answer is out there through the larger subject matter expert pool of people in Canada and globally, is probably the right approach to solving the more complex data-centric digital twinning capabilities, etc. But it starts really on the ground with the basic question is, how can we help you avoid a problem that you have right now?
And that's interesting as well, because as you mentioned, it really is sort of this everyone sort of going on the same path together and working with that ecosystem and making sure that ecosystem is ready. And Siva, you also mentioned previously, in order to really have sort of that real-time control of certain manufacturing processes, you need sort of that, 15 millisecond round trip, I think you mentioned, right? And I think you also touched upon sort of the point that, this was often challenging in a way to achieve with that level of flexibility and mobility and also reliability that was required for a lot of these mission critical processes. But how ready do you think that sort of ecosystem is in being able to accept that, hey, we can now do this with a private 5G network?
Yeah, that's a really good question, because our customers don't come to us saying, hey, I need multi-access edge computing. They actually tell us, I have a problem and I need to fix that problem. So translating that into, okay, you need an edge compute node. What's your preference of development ecosystem? What are your CI/CD tools that are you using? How do we make this solution seamless to you to sort of run your application that you may own or your third party partner? That's the real challenge. But the technology is there to solve a problem, but first you have to have the right type of problem to solve with technology. So we don't overpromise this is the solution to everything. Although it sounds like, this is great. It's very fast, down and up. You can 10 times the capacity of LTE. So you connect so many other devices, and we tend to over-engineer, to make sure that it's going to be future-proof. I think modular building capabilities that sort of stitched together is the right answer. And you don't want to go in there. For example, a farmer in an agricultural field, their expectation of what they need in order to solve their problems in their business from a pay-per-use is very different from one that is looking to do that in a manufacturing field or on a mine. So there is no one solution fits all, and anyone who claims that, I'd like to challenge them. But there is the approach which fits all, which is, okay, we forget all the vendor names, forget all the, the 3GPP naming. I think what matters now is, here's the problem you're trying to solve. Then the ecosystem evolves with the needs, as we just talked about. So it may be we saw this real life example when we worked with a hospital, and all they needed at the beginning is to make the life of the medic in the ambulance, in the field, better. What we saw when we started talking about what is it? We lived their life. We walked in their ambulance. We talked to the medics, interviewed to understand how they did their business. We created that empathy with the problem. Then we came back with a solution which was very simple. You wear a wearable like a HoloLens. Now you have video feedback to the emergency room instead of just voice. And that sort of immediately evolved. With the cameras on, it's actually seeing all the different parts of medical supplies that the medic is reaching for, that we can track the logistics of that. We can actually tell you how much do you need to refill by the end of your shift. So you don't actually have to open every door again and count. So, and then from there, if you need help, changing an oxygen tank, or you have a technical problem with the ambulance, you no longer have to wait for somebody to come and fix it for you. We can give you guided support. So that's what I really mean, is that sometimes the initial problem may be extremely simple to fix, but it comes with the capabilities to do a lot more. And that's when I think the technology adoption becomes real.
I think going back to the ecosystem, or the readiness of technology question, there's one major area we cannot hide, is the devices. We don't have enough devices, so the technology on the device side is still catching up. So you do have a reasonable amount of mobile phones, and that the general purpose devices. That's where the mass customer is. That is picking up all right. However, when you come to the machine interfaces, this is why I was talking about this 15 millisecond thing. There is no device that can, the device in itself will kill about like 5 milliseconds. Then, what's the whole point? So, very good thing is like we realized in the first few months of our 5G journey, and then we started building our own devices, because every hop you're trying to add from, a machine to an analog to digital converter and a gateway and 5G and all the way back, every hop adds latency. So we had to build our own device. So that's taking the readings from the machine and writing it onto the 5G radio. It's all done in one memory space. So it's kind of a near zero latency. We need to do that way. Again, like this will come eventually, but that's a kind of an area it needs to be looked at this stage.
Yes. I mean, this one other factor is we see spectrum. The spectrum coverage, in a country like Canada, which is huge geographically, second largest in the world, especially in the industries as mining and manufacturing. Again, depending on the need, you're right, the combination between device availability. And then I say it's early days in terms of that usually in any technology, we saw this 2G, 3G, 4G, 5G, consumer devices are the first to go and be ready. And then the manufacturing or the enterprise devices come in trailing a little bit the functionality, but they eventually catch up. But spectrum and the regulatory landscape, which differs from one country to the other, if it doesn't allow for a sort of use cases, and we're seeing this. I mean, we're seeing that manufacturing, which is usually in, I would say, maybe rural, but still, there is coverage, public coverage out there, but they want specific indoor coverage that is very different. As a maze of heavy metal structures that we have to provide coverage through. And then because they're, again, mission critical capabilities of public safety of the workers, etc. how do you do that, but still offer that the same device that's on a wearable still works, or a robot that sort of works in the yard. Once it steps outside of the yard, go to the shipping, still has the connectivity. That sort of indoor, outdoor, macro, and in-building layered coverage is something that we do very well as telcos for our network publicly. And then you have that gray area where how long you're going to do this within private and public. But maybe the answer is a slice, a geographically limited slice in a specific zone that gives the macro coverage to the mine or while still maintaining the public coverage for other devices and their needs, and governing the rules or moving from one slice to the other, etc. So I think the device ecosystem, I mean, we looked at multiple devices to see what we can do from POCs and pilots. And the one thing that is clear now that, they start out with a maximum of 8 slices. Well, that sounds great to begin with, because there's not going to be a lot of slices to begin with. But eventually that needs to evolve. And that's, again, the maturity of the chipset manufacturers. And I like Siva's approach, because sometimes the answer is, let's just put it together. But then the economy of scale kick in. If you're not going to be producing 20,000 of those, it's going to be fairly expensive. So that's where we reach out and say, you know what, Siva, you might have a device. I might have a few thousand users that want to use that device. Let's talk.
I've seen what Siva's built, and it's very interesting. I have to say, on the spectrum and the slicing, I see opportunities for slicing, but I also see, in the case of like a mine, where you're just not going to have very much coverage. And mobile operators, they have a serious priority of where they're going to put 5G, when they're going to put 5G. And most of the operators I talk to, maybe TELUS is a bit different, won't really deviate from that schedule, because they've got a schedule going forward. And that's why I think in some cases, slicing makes total sense. In some cases, it's going to be a bit of it will be a perfectly private network. To add to that is the private network really allows that company to have everything they want and can disconnect from the world. One of the aspects that I see in a private network for especially like a mine or even a manufacturing plant of critical equipment, whether it's for the aerospace or for healthcare, is that you could disconnect it from the world. Bad stuff could happen everywhere, and they can still run and do their business just as long as they've got power. And if it is critical, they will have power. It's not even provided by the provider like TELUS or Cellnex. It's provided by them. So that's one thing. And with regard to devices, yes, we need more devices. Absolutely more devices. And I think I've seen exponentially an increase in the number of devices available over the last year, and I think it will continue to increase. But again, I think you both said, if you can sell 50 million or 20,000, what are you going to build? You've got a plant, you don't have to reconfigure your plant, you can just build 50 million. So I think it's a real shame that it's, because that's where the transformation for our industries are going to happen in being able to use those devices. And then finally, on your commentary, 5 milliseconds, 15 milliseconds, 20 milliseconds, 30 milliseconds, our customers, and I think I can speak for you, Samir, as well, is they don't really care how many milliseconds. They just want it to do what they want it to do. And if 2 tin cans and a string work, that's great. But it just has to do what they have to do. And this sort of evolution of lower latency will come as we develop 3GPP, all these other things. But frankly, 3GPP are a bunch of numbers and letters that our customers don't care about.
I'd love to see our secure by design, resilience by design, and private by design audit an architecture between 2 cans and a string. I'd love to see what they come back with. Because, although it's a joke, but the reality is everything we touch needs to be governed by those principles, because we deal with very complex problems, and of course our customers insist on us having that sort of check mark. But yeah, that has to pass that test first.
Yeah.
So just aware of time. Fortunately, I know we could continue and go on for a while, but I think maybe some final comments. So maybe Steve, I want to start with you. What are you most excited about in the next 12 to 18 months, and what's the focus for AMRC?
I think we are now in a stage, we've solved the initial problem of 5G. We all understood how it works, what it takes to get it configured. Now we are in a stage that it needs to transit from the R&D environment, what we do here, into real product production. So that involves bringing in, handing over from the engineers and researchers into to an enterprise manager, so that they don't really, coming back to Catherine's point, they don't really care about the numbers and all of those. They need to get something to work. I think we are coming very close to that at this stage. So eventually we'll be pushing through the doors, and then I think that's the most exciting thing. Yeah,
and Catherine and Samer, maybe Catherine, I'll start with you. Maybe very quickly, what's your area of focus for the next 6 to 12 months?
The next 6 to 12 months are, well, we've deployed over 50 private networks, both 5G and 4G. And it's really taking our existing customers to the next application, the next application, the next application. And then also we are focusing, as you know, on manufacturing and mining, oil and gas and energy, and transport and logistics, and really focusing on developing new customers and new applications in those areas.
That's interesting. So not just deploying it for a single use case, but scaling that across the business in a single site, and also maybe potentially across multiple as well. And Samer, what about you?
I think what we started last year and the year before is a journey of learning. We're learning what our customers hold important as a priority. And we talked about worker safety. We talked about increase in production. We talked about sustainability, which is also very important. And on that journey, evaluating the right solution. To me, it's always about the end output, but also ensuring the resiliency, privacy, and security by design are all checked off. I think I'm very positive about the outcome of the adoption of the technology, because it does work. We've taken this, we've sold it, we have it in our labs. I think the adoption with regards to the availability of various devices is going to evolve very quickly, positively. And last but not least, I think Catherine gave us the solution now. 2 strings, 1 string and 2 cups will probably get 90% of those problems solved. But joking aside, I think that it starts with a simple conversation, especially in those areas. It becomes very, very complex very quickly. So you really need to get the basics of what you're going to serve and how you're going to serve the customer with private wireless, edge computing, the access to very flexible radios that don't require a lot of work to deploy. I think those are the basics that get us in the door for a 5G adoption in these 2 areas.
Great. Samer, Catherine, Siva, thank you so much. Really sort of great discussion here. Annie, I'd like to pass that back to you.
I'd like to add my thanks. I thought that was terrific, actually. And I've really, really enjoyed today's session, because I think there've been a lot of insights, and it's stuff once you know it, it's like, oh yeah. But until somebody points it out to you and gives you some empirical evidence, it's really not that obvious. And I think it's not just about technology and a lot of insights into technology deployment we've had today, but into a whole raft of other issues that come into play too. So I think it's been a fabulous conference. Thank you for a terrific panel. We do hope you'll all be back.